Okay, so let's say we have a bag of marbles. And we have some colors and some probabilities here. Okay. Make a little chart here. Green, red. We'll say green, red, and blue. Alright? Let's say the probability of getting a green is 0.5. The probability of getting a red is 0.3, and blue is 0.2. So first of all, is that a valid distribution probability? Yeah, it is. It adds up to 1. So yes, it is. Okay. Now, let's do a couple examples here. We're going to take one marble. Alright. And then we're going to say, you don't have to know for this. Okay, because we already have the probability. So what you could do is you could say there's 100 marbles if you want to just actually get numbers, because these are just percentages, right? All right, but you don't have to do that for this because you already have the probability. So what's the probability that it is blue or red? This is probability that it's blue or red. That's an or, right? So any blues or any reds count. So that'd be just 0.3 plus 0.2, and that'd be 0.5. Okay? Do we have to worry about overlap there on this problem? We're only taking one marble, so there's no possibility for an overlap. Okay? Let's say what's the probability it is not red? So the probability it's not red means it has to be what? Green or blue. So you add those up. Okay, so that would be 0.5 plus 0.2, so that would be 0.7. Okay. Now, let's keep the same distribution here, but let's say we have two bags, and they each are this. Okay, 2 bags in each of this. Now that's a different problem. And we're going to take one marble from each one. That's a different problem than if we took 2 marbles from one bag. Okay? Everybody see that? If we have 2 bags and take a marble from each one. So 2 bags, take 1 marble from each. Okay? So what's the probability they're both green? What's the probability they both? Well, the probability the first one is green. 0.5. What's the probability the second one's green? 0.5. And what do we do there? They both have to be green, which means it's an and, right? The first one has to be green and the second one has to be green. So that'd be multiplying. 0.25. Okay? And let's do one more here. What's the probability neither is red? What's the probability that neither one of them is red? Yeah, for the first one to not be red, that's going to be 0.5 plus 0.2, which is 0.7. We're adding those, right? Because it can be green or blue. Green or blue, we're adding those and getting 0.7. But then we have the second one, which we have to multiply, and that's going to be green or blue again. So that's going to be 0.7 times another 0.7, get you 0.49. Okay? That's good for today. We're just going to be part of this section today. So homework is on page 728, 1 through 25. Yeah. They're not that hard.